Have you ever wondered about the beat inside your chest? That familiar steady rhythm is more than just a pump. It's the engine of your life, the very beat that powers every single movement, every breath, and every thought. But where did it come from? How did this vital organ evolve from something simple into the powerful four-chambered heart that beats within us today? Let us rewind the clock and take a journey through 500 million years of evolution to uncover the incredible story of the heart. Our story begins more than 500 million years ago, deep in the primordial oceans of Earth. Life back then was incredibly simple. Single-celled organisms floated freely, absorbing all the nutrients they needed directly from the water. They didn't need a heart because they were so tiny that oxygen and food could just diffuse right into them. Easy. But as life got bigger and more complex, this simple method wasn't enough. These new multicellular organisms needed a way to move nutrients and oxygen around their bodies efficiently. This was the moment the very first seeds of circulation were sown. Let's look at some of the earliest animals, like flatworms. They didn't have a true heart, but they developed a network of tiny canals to transport fluids through their soft bodies. It was a start. Then, as evolution marched on, annelid worms, like earthworms, developed a much more advanced system. They had muscular blood vessels that could contract rhythmically, actively pushing blood through their bodies. This wasn't quite a heart as we know it, but it was the ancestor. It was the birth of the concept of pumping life. Next up on the evolutionary stage were the arthropods, creatures like insects, spiders, and crustaceans. They developed a simple tubular heart. Picture a long hollow tube running along their backs, pumping blood through open spaces inside their bodies. It's a bit different from our system. Their blood, called hemolymph, mostly carried nutrients, but not oxygen in the same way ours does. For that, insects use tiny openings on their bodies called spiracles to breathe. Still, this tubular heart was a massive leap forward. It was a biological innovation that allowed creatures to grow bigger, move faster, and eventually conquer the land. The next great transformation came with the arrival of fish, the earliest vertebrates to develop what we'd recognize as a true heart. The fish heart was a two-chambered pump, one atrium to receive blood and one ventricle to pump it out. This simple but effective design sent deoxygenated blood to the gills, where it would pick up fresh oxygen from the water and then circulate it through the rest of the body. This system was perfect for life underwater, where oxygen exchange happens directly with the environment. But evolution is always pushing boundaries. When some pioneering fish began to venture toward land, they faced a brand new challenge: how to breathe air. This is where amphibians, like frogs, hopped into the picture. Their hearts evolved a third chamber. This was a game changer because it allowed for a partial separation between oxygen-rich and oxygen-poor blood. This clever adaptation helped them survive both in the water and on land, making them true masters of two worlds. It wasn't a perfect system, though. Some of the oxygenated and deoxygenated blood still mixed, which meant it wasn't as efficient as it could be. But it was a crucial stepping stone. When reptiles appeared on the scene, the heart became even more specialized. Many reptiles, like lizards and snakes, developed a ventricle that was partially divided by a wall of muscle. This significantly improved the separation of oxygenated and deoxygenated blood, giving them more stamina and energy. This adaptation was so successful that it helped reptiles dominate the ancient world for over 200 million years. But evolution wasn't finished yet. The best was still to come. In the age of birds and mammals, a true revolution occurred: the creation of the four-chambered heart. This design completely separated oxygen-rich and oxygen-poor blood, creating two distinct circuits. This maximized efficiency, allowing for a high metabolism and the ability to maintain a constant body temperature, something we call being warm-blooded. For birds, this powerful heart fueled the immense energy required for flight. For mammals, including us, it powered the rise of intelligence, incredible endurance, and complex social behaviors. The four-chambered heart was, and still is, one of evolution's greatest triumphs. So, how does this masterpiece of biological engineering actually work? Let's take a quick look inside. Each of the four chambers has a very specific job. The right atrium receives oxygen-poor blood that has traveled all around your body. From there, the right ventricle pumps that blood to the lungs to pick up a fresh supply of oxygen. The newly oxygen-rich blood then returns to the heart, entering the left atrium. And finally, the left ventricle, the most powerful of all the chambers, pumps that oxygenated blood out to every single cell in your entire body. Together, these four chambers create the iconic looped-up sound we associate with life itself. What's even more fascinating is how our own hearts develop before we're even born. In a human embryo, the heart starts out as a simple straight tube, just like the hearts of our distant invertebrate ancestors. Then, as the embryo grows, this tube begins to twist, fold, and divide, forming the four distinct chambers. It's like watching the entire evolutionary journey of the heart play out in miniature, right inside the womb. So, every single human heartbeat is more than just a biological function. It's a living echo of hundreds of millions of years of evolution. Today, scientists study the hearts of all kinds of animals, fish, reptiles, birds, and other mammals to better understand our own. By comparing their DNA, their structures, and how they develop, researchers can trace the evolutionary steps that connect us to every creature that has ever lived. Even the tiniest frantic heartbeat of a hummingbird or the slow, steady pulse of a frog tells a part of this incredible story. It reminds us that life's greatest rhythm has been playing since the dawn of animal life. Think about it. The heart, an organ that began as a simple pulsating tube, has become a universal symbol of love, courage, and vitality. It's the one organ that connects all living beings, from the humble worm to the magnificent whale, from ancient fish to modern humans. Its evolution tells an epic story of survival, adaptation, and the incredible, relentless creativity of nature. So the next time you feel your pulse, or hear your heart beating in a quiet moment, take a second to appreciate it. Remember that it carries not just your blood, but the history of life itself, a profound and powerful rhythm, billions of years in the making. Thank you so much for joining me on this journey through time. If you enjoyed this video and want to explore more incredible stories from the natural world, don't forget to like, subscribe, and hit that notification bell so you won't miss our next adventure. See you next time!